Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about what is machine learning. So for quite some time people have been talking about machine learning, artificial intelligence, data science, and it is good to know what all of this means. So today we'll focus on one of those concepts, which is machine learning, what it is, the application advantages, what's the whole process. Let's just get started. So first of all, what is machine learning? So as the name suggests, it is about a machine learning about a certain problem and then giving a solution. So it's an approach to learn complex patterns from the existing data. So how will a machine learn what needs to be done? So it will look at the past data, it will try to analyze and look at what should be this pattern that will come up later on, or what should be the prediction on any unseen data. So it looks at the past and it predicts future. It is easy for a machine to do that because it can process tons and tons of information, GBs or terabytes of information, discover patterns there and apply those patterns on the unseen data. So this whole thing or prediction that the machine does looking at the past is known as machine learning. If we look at artificial intelligence, it's a bigger superset, and machine learning is a subset of artificial intelligence. We can also say it is a study of making machines more like humans. So we are trying to depict the human behavior in machines so that they can make better informed decisions, because a human being will have or will be limited by their own capacity to process and assimilate data, but machines don't have that limitation. So if we can teach them to mimic human brain, which is what neural networks are, but today we are just not focusing on neural network but only machine learning. But essentially we want machines to mimic humans and make decisions, well informed decisions. That's what machine learning means. If we have to do a differentiation between how a traditional program was versus how an ML program looks, so traditionally we have been writing programs or we have been building software for decades now. How does a traditional program work? It is simple. We give an input, which is data or any kind of input. We ourselves write an algorithm, then we write a program and we feed that in, and based on the program that we have written and taking the inputs that we are giving, it produces an output. Here the whole onus or accountability of writing the program is on us. We are the ones who write the logic based on what output do we need. So that's a traditional programming way. But when we talk about machine learning, the beauty is that the program doesn't really have to be written, or let us look at this way, that we are giving both input and output to the machine. So looking at the input and the output, the machine understands that if we are giving this kind of a input and the output comes out as this, so it can understand those complex patterns and this whole scenario of what input will produce what kind of an output. So it is actually giving you that program. Okay, so it's a bit of a shift from traditional programming, but I'm not saying that in machine learning everything is auto built. We do build our own models, we fine tune it, that process is there, but it is more about making a judgment, looking at the previous data or looking at the input and output. It tries to understand how it should behave in the future. So very simplistically, if we want to look at the ML process, what does it do? There are primarily three major areas that are there. First is training, second is validation, third is testing. What does that mean? So training is the part where we are teaching the machine to behave in a certain way, or we are teaching the machine to predict patterns. What we do if there is a huge amount of data, let's say, let's take a simplistic example that we are trying to do a fraud detection. We are looking at some credit card transactions. We want to predict whether there will be a fraud or not. So what we do, we take past data, which has multiple parameters, like it has somebody's information like their credit balance, the spending pattern, etc., right? That's the whole data. In that data, there is already an outcome which says that, okay, this is the outcome. What are the cases where actually a fraud happened? Let's say it's just a yes and no output. Now, what we do, we look at that whole data set. We take 60% of that data typically for training. We feed the machine this whole data along with the outcome. where we say, now there are different types of machine learning algorithms, supervised, unsupervised, all of that, but for simplicity sake, I'm just taking this example where we are feeding in the output also. So it is supervised, where we feed in the output, we say, okay, these are the type of transactions that happened, this is the output of whether it was a fraud or not. Now that training data set is used to train the machine, looking at all the patterns on the data, saying that, okay, these kind of transactions would lead to a fraud. That's the first part. Let's say on the bulk of the 60% of the data set. Then comes the validation, where we validate whatever was built, the model that we built, it is correct or not. Now, validation is different from testing. Okay, testing is where we do not give an outcome, we just give the input, we run our model, and we see whether it is producing the desired output or not, because we know the output now beforehand. It's a iteration that we keep on doing to make our model better and better and accurate. So that is what is the whole process of doing this, building this ML model. Now, in these three phases, we are taking the same data set that we have, but dividing into three parts, where majority is for training, some part is for validation, some for testing. Even for testing, we know the outcome. So we are just testing our models to see whether it is predicting the right outcome or not. Once we have built that model, doing multiple iterations, and usually we may build multiple models, run them, see which fits better, all of that. Once we are convinced, that is when we actually run on a data where we don't know an outcome, and we try to see what is the prediction. So in a nutshell, these are the three stages in which a ML model goes through. This is a more elaborate process where what is actually happening. So the first step in any ML model building is data preparation. This is the most critical and the most time consuming phase. The reason being, in the big data world where today we are in, there is huge amount of data, sometimes terabytes of data from different sources. For example, for the credit card example that I gave, we will have some spending pattern, we will have the time at which the transactions were made, we would have the some of the information about the customer per se, his salary and all of that, right? So it is multiple types of data coming in from maybe different systems. So first part is that data ingestion, collecting that data and doing the prep means we figure out what data we actually need from there. We do null value checks, null values are removed, there are certain conversions that need to be done on the data from integer to string, etc. So there are multiple phases in data preparation. We will not go into the details for today's video, but later on I'll make a dedicated one. So data preparation is the most time consuming and the most valuable step in this whole process. If we prepare the data well, so it's like if we feed garbage, we'll get garbage only. So the most critical step is to prepare the data, feed some sensible data that is required to build a model and get good output. Once the data prep is done, out of this data set, we divide it into training, test, and validation also. But here I've just written about training and test. So look, maybe let's just think about training, validation together and test as a separate data set. So as I said, training and validation is more about giving the model, building a model, giving it some data where the outcome is already there, and then applying that to the test data set. Then comes, after doing this data set division, comes the feature selection, which means what are the parameters in the data, or what are the attributes in the data which can be selected to predict the outcome. So if I am looking at fraud detection for a credit card, what are the parameters? Maybe salary can be one good parameter, because based on the salary I will see the purchase pattern. Time of purchase, usually the time of purchase can be a good parameter. Kind of things that the person purchases, that attribute can be a good feature selection. So out of the data set, because it's a huge data set coming from different places, it may have multiple attributes or columns. But what is relevant to build a model for fraud detection is what is known as feature selection. After we do the feature selection, then comes training different models. So what we do, we create models. Now models, there are multiple algorithms that can be used to do a particular problem. So we can build multiple models. It's not one model. And within each of these models, there is this whole iteration going on where we keep on selecting features, deselecting features to see which model gives me better accurate results. So this whole of the process goes on different models, within the different model by feature selections. And there are multiple passes over the training data just to do this whole checking of what features are giving me better result, what model is giving me the better result. Once, and this whole process from data prep to multiple passes, it will take a lot of time for us, and it is a repetitive iterative process. It's not one shot. After this is done, this trained model is used on the validation data set to do prediction, and then on the test also. So this whole process is where we are actually building a model which can be used in future on a data where outcome is not known, and the purpose is to predict the outcome. So these are the steps. Now the last thing that you see here is MLOps. ML operations. Just like DevOps, we have, or SecOps, we have MLOps. MLOps is a very, very important fundamental process, because when we build a model, it may work on the data set that we built it on, right? But with time, we may get newer data, we may get multiple other features that are relevant. So we have to keep on doing this process where we have built the model, deployed it, we are running that model, we are getting input or feedback whether that model is predicting correctly, not correctly. That needs to be fed in. The model may be sometimes rebuilt and redeployed. So just like in our development, we have this code that we write, we unit test, system test, we deploy in different environments, we get bugs, and then we repeat the cycle to apply patches, bug fixes, that whole maintenance. Similarly, in an building of a machine learning algorithm, there is a MLOps needed, and these days you will hear rampantly people talking so much about MLOps. It is a bit more complicated than our DevOps, because we are dealing with a dynamicity in terms of data where it is affecting our model and the predictions it is making. So there is a constant need to keep on monitoring what it is predicting, what is the accuracy level, what is the feedback we are getting, and retrain, redeploy, rerun our model. So this is the whole 9 yards of what we do when we talk about machine learning. Okay. Um, then moving on to applications. Applications is where all are can be used. So this is very small list. Machine learning can be used in n number of domains in n number of areas. But I have just put together some examples to make everyone understand what machine learning is capable of. It's just the surface that I'm talking about. That there's much more we can do. So simple things like image recognition, speech recognition, traffic prediction, product recommendation. One of the most widely used that we all have seen is product recommendation, based on our patterns, based on our interest, based on people of our similar background, what interest do they have, what they have purchased. It shows as product recommendations, whether it is Netflix, Amazon, Flipkart, any of the e-commerce websites or OTT platforms, they do this. So this is the most common use case. Speech recognition, of course, it is there. Then self-driving cars, cars like Tesla and others, where there is a self-driving capability, they are using machine learning to predict how to drive on a road. Email and malware filtering, fraud detection. This is also one of the use case. Then there are online assistants like Alexa, like others. And then we have, so these are some of the use cases. There are use cases in the medical field as well. So for diagnosis of diseases based on whatever stats we are capturing, based on past medical history, it can actually do a lot of prediction in terms of what may come up, what disease may come up, how it may affect a patient. So there is no dearth of opportunities where ML can be applied. Any field, any place where we see that there is a lot of work that we are doing today in terms of prediction, or in terms of analyzing something, we can definitely apply machine learning algorithms. Now, this was a very quick overview of what is machine learning, applicability, the whole process and importance. I hope this helps you to get started on your journey. Going forward, I will make videos for each of these topics that we spoke about today in detail. So thank you very much everyone. Keep liking, sharing and subscribing to the channel to get more interesting videos. Thank you.